Chapter 9, inferences from two samples. Here we go. So we're going to have two proportions. So p hat 1 minus p hat 2. Here are the formulas. Your ho is going to be p1 minus p2, and your ha, p1 minus p2. So this is usually going to be equal 0, and then clearly these symbols. Here's your test stat. That is a big formula. This actually pisses me off. I should have had the Z right here. Where's my whiteout? I hate when the equal sign is not aligned with the fraction bar. All right, this P is x1 plus x2 over n1 plus n2. This is called the pooled proportion. And you only use it with a hypothesis test. 2 prop z-test is the button that we use in the calculator. And the degree of freedom is, we're just going to use the calculators. There's a long formula for the degree of freedom, and it's not worth it. Okay, for a confidence interval, it's this. Plus or minus critical value. But we don't use pools here. And 2 prop z int. Be the buttons in the calculator, and remember, just remember, so p hat 1 is going to be x1 over n1, p hat 2, x2, n2. Okay, here you have it. If we were taking a test in class, you would have all of these notes, and same thing, if we were having a final, you would have all these notes. Okay, I would never make you memorize this stuff. All right, here we go. A research team conducted a study to test whether a drug lowers the chance of getting diabetes, or diabetes. I don't know which way it's pronounced, but if you know Wilford Brimley, then you know that commercial about diabetes. All right, who has not seen that commercial? Wow, okay. Who does not know who Wilford Brimley is? Holy cow, that's a staggering number. Let me see if I have a picture of him to show you who Wilford Brimley is. Jeez. All right, so I always keep photos of Wilfred in my calculator. Okay, there he is here. You've probably seen him around. All right, a true statesman, a true cowboy. And yeah, so always keep photos of Brimley on hand. All right, in the study, 2623 took the drug, 2623, and 2646 took the placebo. The results are shown here. So 17% on this drug got diabetes, and the placebo 18%. So it looks like the drug is lowering it, but is that enough of a lower to really make a difference? I mean, when you're talking about the millions of people who have diabetes, that 1% could make a difference. I don't know. So test the claim that the drug lowers the chance of getting diabetes. So HO. So, all right. P hat 1 here is 0.171, and that's N. N2. So P hat 2 is 0.185. Okay, so P1 minus P2 is 0. Because that really implies P1 equals P2. If I added P2 over, which means that there's no difference in the proportion of diabetes versus not diabetes. Your Ha is it's got to lower it. So P1 has got to lower P2. You could leave it like that, or you could subtract P2. So it'd be P1 minus P2 is less than 0. So either one of these is okay. The test stat is going to be P1 minus P2 minus P1 minus P2. Here's the formula. P pool, Q pool times 1 over N1 plus 1 over N2, square root of this whole thing. All right. That's the test stat. So P1 minus P2 is 0. Okay, now we got to find the pooled proportion. Well, first we have to find X. So remember, P hat is X over N, so 0.171 is something over 2623. So if I cross multiply, X is about, I'm just going to round to the nearest integer, 449, and take my word for it here, 185 times 2646. This is 490. That's X2. So my pool is X1 plus X2 over N1 plus N2. .178. Okay, now what this pooled proportion does is it takes the average of people that have diabetes. All right, so the average between 0.171 and 0.185 is this, but it slightly weighs them based on the denominator that you're using, so based on the number of people that you have. So 0.178, that's P pool times Q pool, 1 minus 0.178 times 1 over N1 plus 1 over N2. So I'd have to crunch this, disaster. Let's do this in the calculator. Stat test, 2 prop Z test. So X1, 449, N1, 2623, X2, 490, 2646, and it's less than. Calculate. Ta-da. Oh, this is Z, not T. Duh. So Z equals negative 1.33. So that's your test stat. That's the p-value. That's the p hat, which is there. That's the other p hat, which is there. There's the p pool, 0.178, which we found. N1, N2. All right, so there's the Z. Now, since it's less than, that's norm CDF, negative 99, negative 1.3301. That's how you get 0.09. So since my p-value is greater than alpha, fail to reject HO, so there's no evidence to say it lowers it. The drug lowers the risk. It's just not strong enough to say that it's actually doing something. You could have found that by random chance. Maybe you randomly select these patients again, put them on the drug, and that could be higher. So, all right, that's the hypothesis test. Test a claim using confidence or critical values. Nope. Let's do a 90% confidence interval. So the formula p hat 1 minus p hat 2 plus critical value p hat 1, q hat 1, n1, p hat 2, q hat 2, n2. We're not pooling here. So 0.171 minus 0.185 plus or minus inverse norm 0.05 because it's 90%. 0.05, 0.90, 0.05, 0.1 times 0.171, 1 minus 0.171 over 2623. That's 1 minus 0.185, shoot, over 2646. No way am I doing that by hand. Stat. There we go. 2 propsy in, not 2 sample. That's for means. 2 propsy in. Enter. The X's are already in there. Let's change that. 90. Calculate. There we go. Here's the answer. Well, that'd be no change. Well, it's actually 0.003. All right, so since the HO, which is P1 minus P2 equals 0, and the 0 part is in the interval, we fail to reject HO. So the drug appears to be lowering it the drug's lowering it from 0.3% to 3%, which that's useless. I mean, I guess if it's all you have, yeah, but the side effects include this list. All right, headache, diabetes itself again. Let's see, migraines, irritable bowel, ulcers, bleeding stomach, lupus. It goes on and on with these drug commercials and all the side effects. Nope. All right, here we go. Test a claim using a hypothesis test that the, I don't want to do another lowered. Let's do here. Can you reject a claim the proportion of occupants who wear seatbelts is the same for passenger cars and pickup trucks? Well, this is a great study. Are the proportion of people in passenger cars wearing their seatbelts at the same proportion of pickup trucks, all right? Amazing study. Probably spent millions trying to find it. All right, so that's P1, P2. So that means no change. That's no difference. Because if they're subtracting a 0, then there's no difference. And is it the same? We get that. So let's just do this right in the calculator. So 2 prop C test. Now this gives us the X, 129, 150, 148, 200, and it wants the same. All right, so the test stat is 2.73. The p-value, 0.006. P hat 1 and P hat 2, we already have these. I'm not going to copy them down. That's the P pool, 0.79. So since p-value less than alpha, we reject HO, so there appears to be a difference. One would suggest that pickup trucks are wearing their seatbelts less. So based on this, I would guess that the pickup trucks are lowering it less. So if we did a confidence interval, is that, and what does it want? Who cares? Let's just do 95%. And this is what we got. All right, so since HO P1 minus P2 equals 0 is not in the interval, we reject HO and then blah, same sentence we would say here. So it appears, or it suggests, the pickup truck drivers or whatever are anywhere from 4 to 20%. What's this asking? Trucks that are anywhere 4 to 20% lower in terms of proportion. Wearing seatbelts. Okay, we'll stop there.